Hi, through this project, I'm going to demonstrate how compilers work and how a new programming language is created. So here I have created a new language called console game language, where the code looks like this, and you can use it to create very simple programs. Let me try to run this file. When we run this program, it looks like this. A new retro console pops up with some buttons, and when you press power button, the game starts. So all the logic that is being executed in this program is written in this language. Let me show you another example, this time numbers.cg. Okay, so it's a very simple program where you can just have a counter and you can increase or decrease the counter. Or you can press the start button to give you a random number between 0 and 100. Okay, so now let's see how to write program in this language, and then we'll see how that is compiled and that can be rendered on the screen. So the simplest program that I have here in this language is this. So this language works on states. So for example, this is a state here which starts with a tilde symbol. So the program starts with the initial state where the program is going to be initially, and the definition of the state is here. Inside the state, you have instructions which are to be executed in that state. And at every frame rendering, those instructions are going to be executed. So in this case, what's happening in the initial state, which is the X state, it is displaying this shape at 10, 10. Okay, so the shape is defined with a pound symbol in the beginning, and it is defined something like this. The definition contains just an array of pixels where the pound denotes a lit pixel and the dot denotes an unlit pixel. So let me try to run this program and we'll be able to see what it looks like. Okay, so this is the program and it's pretty simple. So it went to the X state and it has shown this X shape, which was defined here at 10, 10. Now, this console has a screen of 30 cross 30 and it is running at 30 Hertz. That is, there are 30 frames being rendered per second. So here this X state is being executed 30 times. So we are doing this 30 times per second. Now let's try to extend this program a little bit. So add a few more states and add a button handler. So that will show us what it is. So here we have the modified program. What we have done here is we have added another state called O shape, sorry, another shape called O shape, which has a 3 cross 3 O and another state defined called O state. And what's happening here is that our initial state is still X, and in the X state, we first clear the screen, then we display the X shape at 10, 10, and this is a button handler. So on pressing start, this instruction is going to be executed, which says go to O state. So this is going to jump us to O state, which will again clear the screen, display the O shape at 10, 10. And again, it also has a button handler, which when pressed, it goes to X state. So basically on pressing start, we are going to jump between state, and this state shows X shape and this state shows O shape. So let's try to run it. So here's the program. It is initially in the X state. These instructions are being executed again and again. So it is clearing the screen, it is displaying the X shape, and so on. Now, when I press start, it executes this instruction at line 20, which says go to O state, and it jumps to O state. And now this is executing these instructions, clear, display O shape, and so on. So yes, this is the simple program that we have. Now let's see how this is compiled. And yeah, so let's take example of this program. So initially, this is just a stream of characters. Now we'll see how these are compiled. So the compilation logic is here. So what happens inside the compiler is that it first runs the preprocessor. What preprocessor is going to do is that it's going to do these three things. It removes the comments from the code, it removes the trailing white spaces from lines, and it adds an empty line at the end of the code if it's not present. So basically just basic sanitization is going on in preprocessor. After the preprocessor, there is lexical and syntax analysis. So lexical analysis is basically the conversion of this stream of characters into stream of tokens. Now, what are tokens here? So for example, the state name is a token, the new line is a token, the shape name is a token, and so on. So these are defined using some patterns which are here. I listed all the patterns that this language uses here for the tokens. So if you see, for example, in this case, state name is a token and it starts with a tilde character and then contains one or more alphanumeric characters or an underscore. Similarly, you can see the handler is basically an @ symbol followed by X, Y, A, B, or star, and so on for everything else. Let me show you some other one. For example, consider the shape. A shape is basically just a collection of dot and pound symbol along with a new line. That's how we define all the tokens. And lexical analyzer is going to take this list of characters and turn them into a list of tokens. Yeah. So for this list of characters, the tokens look like this. So for the first is state name, then a new line, followed by a shape name, and so on. Now, once we have this list of tokens, then we are gonna convert this into the syntax tree using the syntax analyzer. So after the lexical analyzer, we have syntax analyzer, which will take the stream of tokens and convert them into a syntax tree. The rules that define how tokens are to be converted into a parsed syntax tree is called the grammar of the language. And the grammar in this case looks like this. So this is the BNF representation of the language, and it is pretty simple to read. So consider it like this. This is the program, and this is going to be the root of our syntax tree. It is basically just a state name followed by a new line, followed by top level statements, followed by new line, and followed by end of file. Now, these top level statements are defined again here. And this is basically top level statements followed by a single top level statement or just a single top level statement. And what is a top level statement? A top level statement is a shape definition or a state definition, and so on. We have defined everything like this here. Right, let me show you some of the more complex example. Look at this one, for example, screen update statement. So screen update statement is either a clear screen token or it's a display shape token followed by a shape name token followed by a coordinate operator, left parentheses, expression, then a comma, then another expression, and then the right parentheses. So this is how the grammar is defined, and the syntax analyzer is going to take this grammar and this series of tokens and convert it into an abstract syntax tree, which is here. So our simple program, this has been converted into this syntax tree. So if you see, the program is the root, and it has just a state name, a new line, one top level statements token, and then a new line again. So this is how it works. Now that we have the syntax tree, this can basically be serialized and stored in a file. And this is our compiled program essentially. But in this case, I'm not serializing and storing it. What we are going to do is that now we are going to run it through the syntax analyzer, which is going to give the meaning to the actual tokens. So for example, the tokens right now in itself don't have any meaning. So an expression, for example, would not make any sense, right? This expression in itself does not have any meaning. So to give meaning to this expression, what we do is we run it through this semantic analyzer, and semantic analyzer is going to give meaning to this. So I'll show you some of the semantic objects that these are converted into. So for example, if I go to this expression object, so this is the expression object, and it's a semantic object for us. So it has a meaning because it can calculate the value of the expression that is inside this particular token. So that's why it's a semantic object. So once we have all the semantic objects ready, then we can just render it using any renderer. Here, the renderer is going to be our Pygame based console, which takes as input this game, which is a semantic object, and it uses the functions within this game to render it. So for example, they can get the pixel array, the console can get the pixel array from this game because it's a semantic object, can pass on the button presses to the game so that it can change the state and so on. And the rendering thus happens. So yeah, that was the overall idea of how we go from this program to actually this rendered output. So let me just quickly take you through all the steps one by one. So first we write this program, which is basically a stream of characters. Then using these patterns, this stream is converted into a list of tokens, something like this. So the program has now been converted to a list of tokens. Now this list of tokens, using grammar of the language, is going to convert it into an abstract syntax tree. And this abstract syntax tree is then going to be parsed into semantic objects, and those semantics objects are going to be rendered here like this. So that's how it works, and that completes the whole compilation and running process.